Okay, this is going to be the lesson for the ratio test. One of the easier tests. I mean, it can be a little messy when you do it, but it's not that bad. It lets you compare things you haven't been able to do before. So basically, it goes like this. You're going to compare, if you had something, I don't know, just making up something like that, you're going to take the n plus 1th term, right? Like if this was the 5th term, you take the 6th term. The 7th term, you take the 8th term. So basically, you always take the next higher term and you compare it to the previous one, right? And you make a fraction out of it, right? That's what a ratio is. It's a fraction. So you make this comparison. Notice there are absolute value bars there. So if you ever see negatives in these problems, if they ever get cute and they put like -1 to the end in there, you completely ignore it because the absolute value will eat it up. So once you make that comparison, you take the limit as n goes to infinity, which I've been doing forever. If that limit is smaller than 1, that means that the original series converged. If the limit's bigger than 1, it diverged. If it's 1, you made a poor choice. It means that this test was not supposed to be applied. Like if you try to do it to something like this or something like this, these are not limit tests, these are p-tests. If you try to do this ratio test here, if you try to do the ratio on these, you're going to get 1 both times. And 1 diverges, 1 converges. So this test is not appropriate for this. What it is appropriate for, and I'll show you. Like, in the very beginning, the very first one, right? We did geometric. And then, we did our favorite, the p-test. But what we have not done is compared these two. Now, when you run through the list, right? Geometric, that's clearly not geometric. Integral test, I don't think so. It's not an integral test, right? This limit is infinity over infinity. Now, if you use L'Hopital a bunch of times, you will get 0. So the limit is 0. So it doesn't fail the limit test. And comparison. What are you going to compare it to? 1 over n? Yeah, n third on top. So, you'd only do comparison test if this was like 5 over 2 to the n. So there's no other test that lets you compare this type of thing. Also, your new best friend is this dude. This dude will show up in the problems also. I mean, you'll get stuff like this. So you have to know how to handle these, and this is what the ratio test is for. So I'll do a quick example just to show you. So, all right, I am going to do an example, but I wanted to erase everything here and move it over to there so it's more convenient. But before I do that, we have to talk about one of the main reasons that they do the ratio test, besides the fact that you can compare stuff like n third, n 4, 2 to the n, 3 to the n, right? You couldn't compare those before. There was no test that would handle them at the same time. So you also start seeing this thing. And unfortunately, you start seeing that thing too. This is less common though in the ratio test. But so what this means is n factorial, as I discussed in class. And what it means is very simple. You're going to create a product of numbers that go down 1 at a time, right? A descending product. So you keep subtracting 1 each time until you get down to the very end and there's nothing left. Like, for instance, if you had 5 factorial, it's 5 times 4 times 3 times 2 times 1. You keep subtracting 1 each time. Now I'm going to write another one under it, 4 times 3 times 2 times 1. For a very specific reason. When you use the ratio test, you are making a comparison, right? You're going to plug in n, which is what you start with, and then you're going to plug in n plus 1, which is the next term in the list. Like I said, if you had A5, the next term in the list would be A6. That's what the ratio test is doing. You're doing a ratio of the guy above and the guy below. And you're trying to see if that ratio is smaller than 1 or bigger than 1. If it's smaller than 1, then I know I get converged. So you're going to be doing this with the n factorial. So what you have is you'd have n factorial on the bottom, say, and on the top you would have n plus 1 factorial. But I want you to look at these numbers. Maybe I should have wrote it down here. Right? Like if this was 4 and then this would be 5, right? Like if n was 4, then n plus 1 would be 5. Now if you look at how these lined up, look at this. This is why I wrote them above each other. These cross out, these cross out, these cross out. So if you were to write that out, right, you'd start with n plus 1, then you would have n minus 1, so on. The bottom one starts at n minus 1, n minus 2, so on. But everything crosses out except for this dude. He's the only one left standing. So really, you could take the top one, right? That's the very first term in the list. If this was 5 factorial, this would be 5. And then you would have 4, 3, 2, 1. So the next thing is just this. So really, you don't even have to write it out like that. You can just say, okay, the very first term is n plus 1. The next one is n factorial. So then you would just cross these out and just get n plus 1. Whatever you want to do. I mean, if you want to write them out, this is fine. But this is the type of thing that you'll see in the problem. So I did say I'd work one, so I'll work a little baby one. So let's say though that you had like 3 to the n, and then you had like n to the 5th over n factorial, right? Now when you do this, you have to do an plus 1 over an, and then you're going to take that limit. What you really end up doing, I'll show you with an easy one before I do the hard one. Like I think that was the first thing I wrote before. If you do n plus 1, right? Plug in n plus 1. Wherever you see n, you put n plus 1. So you do that. And then you're going to divide that by the original dude. Right? You don't want to write this. This is ridiculous. What you really want to do is keep, change, flip. You always want to take the one you started with, flip this over, and put it here to make it easier for you to do this limit. Right? This is too much to write this all out. This over this. This is a pain in the neck. So you want to start the problem. Remember, there's bars here. It doesn't matter if everybody's positive, but there's supposed to be bars here. It's supposed to be absolute value, right? The absolute value is there. That's why if you see a negative, just disregard it. So that's where I want to start. So I'm going to do that with this problem. First, I'm going to take my thing, right? I'm going to put lim, n goes to infinity. I don't need the bars because I have no negatives. I'm going to put n plus 1 everywhere that I see n, right? Replace all the n's with n plus 1. And then do what I just told you to do. Take the original one and flip it over and put it here. This is what you want to do, right? Take the one you started with, flip it over and put it like that. Now, what I do, this is a personal preference. I like to group them by term. But before I do that, I got to start splitting things up. And one of them is here. Using the exponent rules, and I went over this in class. When you split this up, right, the rule is if you have x to powers, right? I'm just using like p and n for power. If you were to times these letters together and they have powers, you add the powers, right? If this is x to the 2 and x to the 3, it's x to the 5th, right? That's the way the rule works. You add the power. So if you're doing the reverse of this rule, you have to split it up like this. This, you're timesing two things that are the same, you would add the powers. So that's how I'm going to split it up. You have to split it up. You have to split all up and start canceling things. So the 3n plus 1 goes like this. Underneath it, now I'm going to keep everybody on top, everybody on bottom, right? All the things on the bottom. I'm going to move this one underneath there because it's convenient for me. I'm going to take the n factorial and I'm going to move him above this one. Now remember what I just did. I'm going to take my n plus 1 off, and what's left over is n factorial. And now at the end, I have this. I have n plus 1 to the 5th power, and I have n to the 5th power, right? This is how I'm splitting it apart. These are going to cross out. These are going to cross out. This is the whole point. This is left over, this is left over, and this is left over. But I want to discuss that on the side. These have the same power. The 5th power, the 5th power. And I'm doing a limit as n goes to infinity. And I always told you in class, take the highest powers. So this is really n to the 5th and n to the 5th. But if you don't like that, since they both have the same power, you can combine them together into one fraction, like that. They both have 5th power, right? How do you do a fraction to a power? You take the top of the fraction to the power, and you take the bottom of the fraction to the power. So that whole thing just boils down to 1. Right? Because you take the highest power on top and the highest power on bottom. Right? Or you can do L'Hopital rule on it. They go away. You take the derivative. They disappear. So, boom. This is 1. So it's gone. So you lose everything. Those crossed out. Those crossed out. The limit of this, since the powers are the same, is 1. So that's gone. So all you're left with then is 3 on top and n plus 1 on the bottom. Now you're going to take that limit as n goes to infinity. My infinity got a little screwed up. So that's 3 over infinity plus 1 is infinity. Hello. And then that's 0. but that's less than 1. So I know that this original thing is going to converge by the ratio test. All right. So this is what the ratio test is not that bad. It's a little bit annoying. You have to be clever about how you rearrange things and split them up and cross them out. But this always happens. You're going to get a limit that is bigger than 1 or less than 1. You're not going to get 1. You're not going to get 1 unless you apply this test where it doesn't belong. Like I said, if you try to do this test with 1 over n squared, that's not the correct test, right? If you can try to do the ratio test with a p-test or a geometric one, it's not going to work. You're going to get inconclusive. That's the whole point. That's why if you get 1, you're screwed over. It means that you failed to identify that it's not a ratio test problem. But usually if you see the factorials or you're seeing these dudes together, like I said, if you're seeing something like that, whoops, this has to be n. If you're seeing something like this, ratio test. All right, so that's a brief explanation. It's like I said, it's the definition. And then, so I showed you how to do it, so it's not that bad. I'm gonna do the root test.